Welcome to our channel with more interesting episode. Yellowstone National Park is currently facing an unprecedented crisis, with officials issuing urgent evacuation orders due to signs of an impending supervolcano eruption. In recent weeks, there has been a dramatic increase in seismic activity and significant changes in Yellowstone's geothermal features, signaling heightened volcanic unrest. The supervolcano beneath Yellowstone is a geological giant, known for its immense size and potential for catastrophic eruptions. Classified as a supervolcano due to its history of colossal eruptions that eject more than 1,000 cubic kilometers, 240 cubic miles, of volcanic material, this scale of eruption is thousands of times larger than typical volcanic events and can have far-reaching impacts on global climate and ecosystems. Recent monitoring has revealed alarming signs of activity. Yellowstone's ground in certain areas has been bulging upward, a phenomenon known as uplift, caused by the accumulation of magma and gases beneath the surface. This uplift, which has reached up to 6 inches in some areas, suggests significant pressure building within the magma chamber, heightening concerns of an imminent eruption. Accompanying the seismic activity are notable changes in Yellowstone's geothermal features, such as geysers, hot springs, and fumaroles. Geysers, which usually erupt at predictable intervals, have become erratic, with increased frequency and intensity. For example, Steamboat Geyser has been erupting more frequently and reaching heights of up to 300 feet. These changes indicate that the underground heat source is becoming more active. Hot springs have shown significant temperature increases and changes in color, signaling chemical alterations due to rising magma. Fumaroles, or steam vents, have also become more vigorous, releasing greater amounts of steam and gas. These geothermal changes collectively point to heightened volcanic activity beneath Yellowstone. In response to these escalating signs, the USGS, United States Geological Survey, and Yellowstone National Park authorities have closely monitored the situation using advanced technology like seismometers, GPS stations, and thermal imaging cameras. These tools provide real-time data crucial for assessing the volcano's activity and informing emergency responses. The decision to evacuate Yellowstone was based on careful analysis and consultation with volcanologists and emergency management experts. The Yellowstone Volcano Observatory, YVO, first raised the alert level from normal to advisory as signs of unrest became evident. Continued escalation in seismic and geothermal activity led to a further elevation of the alert level, indicating that an eruption could be imminent. Evacuating Yellowstone, which spans nearly 3,500 square miles across Wyoming, Montana, and Idaho, presents significant logistical challenges. Coordination among multiple state and local agencies was essential to ensure a smooth evacuation process. Clear instructions were issued to residents and visitors to leave the area immediately, with designated evacuation routes established and shelters prepared to accommodate those displaced. Park rangers, state troopers, and the National Guard mobilized to assist with evacuation efforts, ensuring public safety and orderly departure from the affected areas. Roadblocks were set up to prevent unauthorized entry into the park, while helicopters surveyed remote regions and aided in evacuating stranded individuals. Wildlife protection measures were also implemented, including efforts to relocate animals vulnerable to the eruption's impact. The potential consequences of a Yellowstone supervolcano eruption are dire and far-reaching. Such an eruption would generate an enormous ash cloud, consisting of fine particles of rock, minerals, and volcanic glass, ejected high into the atmosphere. This ashfall would extend hundreds to thousands of miles from the eruption site, with dense accumulations likely within a 500-mile radius. States like Wyoming, Montana, Idaho, and Colorado would experience severe ash deposition, potentially reaching several feet in depth. Inhalation of volcanic ash poses serious health risks, particularly for individuals with respiratory conditions, while ash can contaminate water supplies, disrupt air travel, and cause power outages by damaging electrical equipment. Pyroclastic flows, another hazard associated with supervolcano eruptions, would be devastating. These fast-moving currents of hot gas, ash, and volcanic rock can travel at speeds exceeding 450 miles per hour and reach temperatures exceeding 1,800 degrees Fahrenheit. Pyroclastic flows obliterate everything in their path, incinerating forests, buildings, and infrastructure within a 100-mile radius of the eruption. The immediate vicinity of Yellowstone, including parts of Wyoming, Montana, and Idaho, would face catastrophic destruction, with entire communities potentially wiped out within minutes of the eruption. Lava flows, though slower moving than pyroclastic flows, would still pose significant threats. The eruption's magma could emerge as both fast-moving flows and slower, more viscous domes, engulfing and destroying structures, roads, and natural landscapes in its path. Despite their slower pace, lava flows are relentless and challenging to divert, causing long-term damage as they reshape the affected terrain. Human casualties from a Yellowstone eruption would be inevitable, particularly for those within close proximity to the volcano. The combination of ashfall, pyroclastic flows, and lava would result in widespread fatalities. Immediate casualties would occur within the primary impact zone, with ashfall and pyroclastic flows causing additional deaths in surrounding areas. Emergency response efforts would be overwhelmed, with limited time to evacuate affected populations before volcanic hazards intensify. Infrastructure damage would be extensive, with buildings collapsing under ash weight and critical facilities like hospitals and emergency response centers severely compromised. Transportation networks, including roads, highways, and railways, would be buried under volcanic debris, impeding rescue and relief efforts. Airports in the region would close due to poor visibility and ash accumulation, further complicating evacuation and aid delivery. Environmental devastation would also be profound. The eruption would decimate wildlife and vegetation in affected areas, with entire ecosystems disrupted by pyroclastic flows and lava. Contaminated water sources and altered soil chemistry would have long-term environmental impacts, exacerbating hazards like landslides and flooding in the aftermath of the eruption. In conclusion, the urgency of Yellowstone's evacuation order reflects the severity of the potential threat posed by its supervolcano. Continued monitoring and preparedness efforts are essential to safeguard lives and mitigate the catastrophic impacts of a possible eruption. Understanding the science behind Yellowstone's volcanic activity provides crucial insights into the nature of this threat and underscores the importance of proactive measures to protect communities and ecosystems in its path. When a Yellowstone supervolcano erupts, immediate survival becomes the priority. Recovery efforts quickly shift to providing shelters for displaced people and delivering emergency supplies like food, water, and medical assistance. The economic impact is massive, with billions of dollars in damage and widespread job losses. Rebuilding infrastructure, restoring services, and healing the environment could take years. The emotional toll is also significant, with many experiencing trauma and needing mental health support after such devastation. The effects of the eruption extend globally. A massive ash cloud from the eruption disrupts air travel, as ash particles, composed of rough rock and glass, can severely damage airplane engines. Past eruptions have shown that flight cancellations could affect travel across continents for weeks or even months. The climate effects are severe and long-lasting. The eruption releases sulfur dioxide, forming sulfate particles that reflect sunlight and cool the Earth's surface. Reduced sunlight and lower temperatures can harm agriculture, leading to crop failures and food shortages worldwide. Livestock may also face food shortages, worsening food crises in vulnerable regions. Looking at past volcanic events like Mount Pinatubo in 1991 and Tambora in 1815 provides insight into what could happen. Pinatubo's eruption caused global cooling and extensive damage, forcing over 250,000 people to evacuate and costing billions of dollars. Tambora's 1815 eruption led to the year without a summer, devastating crops and causing widespread hunger. Preparation is critical. Government agencies and scientists monitor Yellowstone using tools like seismographs, GPS, and satellites to predict eruptions. Detailed evacuation plans aim to protect lives from dangerous flows of hot ash and debris. Emergency teams, including firefighters and medical personnel, undergo rigorous training to respond quickly. Modern technology, such as alert systems and social media, ensures timely communication of evacuation orders and safety guidelines. Residents are encouraged to stay informed and prepare emergency kits with essentials. During an eruption, staying indoors can protect against falling ash and airborne debris, with clear guidance on when it's safe to resume normal activities. Thanks for watching. Like and subscribe our channel. Have a good day.